Okay, this video is meant for my geometry students. We do have a test coming up over Chapter 8 on Monday or Tuesday. So this video is meant to prepare you for the last half of the chapter. That's sections 8.4 through 8.6. Okay, so let's start with this problem. It says a meteorologist measures the angle of elevation of a weather balloon as 41 degrees. A radio signal from the balloon indicates that it is 1,503 meters from his location to the nearest meter. How high above the ground is the balloon? Okay, so again, here's this guy. He's on the ground. And there's a weather balloon up above. Okay, there's my balloon. And the angle of elevation is 41 degrees. So from the man to the balloon, that's a 41 degree angle. And there's a radio signal that's sent out from the balloon. So pretend there's a radio signal going out. So this length right here is 1,503 meters. And the question is, to the nearest mirror, how high above the ground is the balloon? So the question is, what is this height? H. Well, there's your right triangle right here. I have an angle, and I have an unknown, and I have one side. This is a trig problem, okay? So based off this angle, 41 degrees, H is the opposite, 1503 is the hypotenuse, the third side is the adjacent, but I don't care about the adjacent. I want to find the opposite. I have the hypotenuse, that is sine. So I'm going to create a sine equation. Sine of 41 degrees equals the opposite H over the hypotenuse 1503. And we go ahead and multiply both sides by 1503 times 1503 times 1503. And that gets the H all alone by itself, and 1503 times the sine of 41 degrees comes out to be 986. And it says to the nearest meter, that is no decimals, 986 meters, and that's the height of this balloon. Always draw a picture, always label your picture opposite, hypotenuse, and adjacent. Okay, next problem says two office buildings are 51 meters apart. The height of the taller building is 207 meters. The angle of depression from the top of the taller building to the top of the shorter is 15 degrees. Find the height of the shorter building to the nearest meter. Okay, so here's the picture. We have two buildings. We have a tall building, right? Here's the ground. And then we have a shorter building. Okay. Now it says the buildings are 51 meters apart. So this distance right here is 51 meters. That's from here to there. The height of the taller building is 207. So the height here is 207 meters. That's the height. Now the angle of depression from the top of the taller building to the shorter is 15 degrees. So we draw a line of sight between the two buildings. And then remember, these angles are formed by horizontals. So here is my angle of depression right here. 15 degrees. And the question is, what is the height of the shorter building? Let's call this H. Well, your right triangle is right here. I don't know if you can see it. I'm going to actually create this dotted line here. There's the right triangle. Here's your right angle. Now this 51 comes up, so this is also 51 meters. And the angle of depression is congruent to the angle of elevation, so that's also 15 degrees. And the idea is, what can we use to help us find this height? This is not part of our triangle. Well, if we look at here, call this x. If we can find this, then to find the height, which is what I want, the height, we can take 207, which is the height of the taller building, and subtract that x. So this is our goal, find x. And we're going to use this right triangle. So in this picture, this is my angle. The opposite side is x. The adjacent side is 51, and the hypotenuse is this side, but we don't care about the hypotenuse. I know nothing about it. Opposite adjacent, that is tangent. Tangent of 15 degrees equals opposite x over adjacent 51 times both sides by 51. That gives us our x by itself, and we have 51 tangent of 15. That is 13.7. I'm going to round it to one decimal place here. And that's meters. So then again, to find my h, and I'll use a different color, let's use blue. To find h, we're going to do 207 minus 13.7. And they want this rounded to the nearest meter. So no decimals. I get 193.3, so just 193 meters. And there's the height of the smaller building. So be careful here when they give you those extra measurements. A lot of times it's a subtraction or even an addition at the last step. Okay, and now the last couple problems here are going to involve variables, different situations, and it's whether you use the law of sines or law of cosines. Okay, so kind of trying to change it up just to give you an idea of what you'll see on the test. So here's a picture. We need to find x. Now, always identify the situation. The situation you are given here is side, angle, side. So side, angle, side means cosines. Law of cosines. So that's how we're going to find x. Now, I will take my picture and label it A, B, C. Across are the lowercase letters. So I'm looking for B here. So in my law of cosines, let's do it over here. B squared equals, finish your Pythagorean theorem, minus 2, these two sides together, cosine of how it starts. Cosine of B. Fill in what you know. B is x. So that's my unknown. A is 7. C is 10. Minus 2 times 7 times 10. Cosine of 48 degrees. Okay? And use your calculator. And your calculator says 55. So x squared equals 55.32 blah blah blah. And we're going to take the square root. And remember to use the A and S button. So second square root, second answer. And I get to 1 decimal 7.4. There's the value of x here, using the law of cosines. Okay, so here's the next problem. And again, always identify what you have. In this problem, I have angle, angle, side. And that means sines. So we need to use the law of sines to solve this problem. So I will label my triangle A, B, C, A, B, C. I am looking for x, so I'm looking for b, so I have to use the b's. Sine of b over b equals, and now I look at my a's and my c's. If I look at a, I don't know angle a and I don't know side a, so probably not going to use the a's. If I look at my c's, I know angle c and I know side c, so I'm going to use my c's. Sine of c over c. And now we just fill it in. Sine of 110 over x equals sine of 40 degrees over, and c is 12. Cross multiply x, sine of 40 degrees equals 12, sine of 110, and divide by the sine of 40 degrees. And we'll put this all in our calculator. 12 sine of 110, close that parenthesis, divided by the sine of 40. And I get 17.5. That's my value of x. So this was a law of sines problem. Remember, two angles, law of sines automatically. Okay, same instructions here, except now we have x and y. So we're going to find two variables. Well, again, start the same way. Identify your situation. This is side, side, side. And side, side, side means cosines. Okay? So we're going to use law of cosines. I'm going to leave on my picture A, B, C, little a, little b, and little c. Now, in law of cosines, you can find either angle first. I always like to pick the biggest or the smallest. So if I look at x and y, x is opposite of 3, y is opposite of 4. So x is actually going to be smaller than y. It's those inequalities from the triangle. So I'm actually going to find x, angle x. So that means I want to find angle A. That means law of cosine starts with side A. A squared equals, finish your Pythagorean theorem, minus 2bc cosine of A. Fill in what you know. A is 3 squared. B is 5 squared. C is 4 squared. Minus 2, 5, 4 cosine of angle A. And I don't know what angle A is, that's x. And here's where you do the three parts individually. So 3 squared is 9. 5 squared plus 4 squared is 41. And this is minus 2 times 5 times 4 is 40 cosine of x. And now we have to solve this for x, so we subtract 41 from both sides. Remember, it's very tempting to combine 41 and 40, but you can't. So you get negative 32 equals negative 40 cosine of x. Then we divide by negative 40. And we get 0.8. This comes out even. Equals cosine of x. And then to find x, we take the inverse cosine of both sides. So really what it says is x is the inverse cosine of 0.8. Inverse cosine. And this comes out to be rounded to one decimal place. X is 36.9 degrees. And there's angle x. So I'll go ahead and put down my picture. X is 36.9 degrees. And now I need to find angle y. Well, you never do the law of cosines twice. Never, ever. So now we're immediately going to jump to the law of sines. And I'll use orange for this one. Now I want to find y. So that's c. So I'm going to use c's. Sine of c over c equals. And now I need to know what I know both of. Do I know both a's? Well, I know angle a is 36.9. Angle or side a is 3. Yes. So we're going to use the a's. So sine of c, angle c is y, sine of c over side c is 4, equals sine of a, which is sine of 36.9 degrees, over side a, which is not 4, sorry, side a is 3. Now I'm going to scroll down. Let's cross multiply. 3 sine of y equals 4 sine of 36.9 degrees. We will divide by 3. Sine of y equals, and we can go ahead and do that, 4 sine of 36.9, you can hold off 2, divided by 3, and you get something like 0.800 blah blah blah, but then you must take the inverse sine of that, because I need y. So we're going to take the inverse sine of this number, and this is just our a and s. So second sine for the inverse sine, second negative for the answer, and the inverse sine of that is 53.2 degrees. Y is in degrees, so we'll label degrees as an angle measure. And there's your two variables, x and y, in this problem. So side, 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 start off with law of cosines, but never do it more than once. Then jump to the law of sines. Okay, so last problem here, and again, another x and y problem. So find x and y, and we look at our picture. This is side, angle, side. So I'm going to start off with cosines. Okay? A is here, B is here, C is here, X is A, 9 is B, 5 is C. So I'm looking for, I have to find X first. Because it's the side opposite the angle given, if you're going to use law of cosine. So that means A. So I'm looking for the A's. I'm looking for A, so A goes first. A squared equals B squared plus C squared. Finish your Pythagorean theorem. Minus 2BC cosine of A. Ends how it starts. A is X. B is 9 squared plus C is 5 squared. Minus 2 times 9 times 5. Cosine, and A is 27 degrees. And we like this because all the numbers are on the right, so go ahead and find it. And when I plug this in my handy dandy calculator, I get x squared to come out to be 25.80 yada yada square root, this is where the answer comes into play, and x equals second square root, second answer, 5.1. And there's that side 5.1. And I'll go ahead and put that in my picture. So not x, it's 5.1. And now we need to find y. And again, you should be able to move on to the law of sines. So y is b, so I need to use the b's. So sine of b over b equals. Now, do I know the a's? Angle A is 27 degrees. Side A is 5.1. Yes, I do know the a's, so I'm going to use the a's. So sine of b. So b is y. We don't know. Lowercase b is the 9. sine of A, sine of 27 degrees, all over side A, which is just what we found, 5.1. I'm going to move it over here. So we have 5.1 sine of Y equals 9 sine of 27 degrees. And then we'll divide both sides by 5.1 to get what sine of Y is. And again, I'll just do this right now, and I'll leave it. So 9 sine of 27 divided by 5.1, and I get roughly 0.80 ... But I need to take the inverse sine now to get Y. So inverse sine of this, 0.80 ... And I take second sine for the inverse sine, and then I'm going to use the answer button, right? Second negative for the answer. And I get 53.2, and that is what Y is. So I'll slide down just a little bit. Y equals 53.2, and it's an angle, so it's in degrees. Okay? So there's just some good problems about law of sines and law of cosines. Remember that if it's a law of sines problem and they give you two angles, that you can immediately find that third angle if you need to. Keep that in mind as you go through the test on Monday or Tuesday. Hopefully this helped. Don't forget about your trigonometry, your 45, 45, 90, 36, 90, and your Pythagorean theorem. Okay, and we'll see you on Tuesday or Monday. Thanks for watching.